Hello everyone, in this video we will solve the question move the zeros. Move zeros basically is a easy question as compared to others. So it is given that given an array of numbers, write a function to move all the zeros to the end of it while maintaining the relative order of the non-zero elements. So it is telling us to move all the zeros to the end of the array. So it is also written that we should maintain the relative order. So relative order is like if the 1 is coming here, so 1 should be coming before the other elements 3 and 12. So we need to maintain the relative order, that is if 1 is coming to the left of 3, it should be on the left of the 3, and if 3 is coming to the left of the 12, so it should be on the left of the 12. So we should not be changing the position of 1, 3 and 12, like 12 comes before 1, so that should not happen. So we need to do it in place without making a copy of array and minimize the total number of operations. So we will see the two approaches. First would be like naive approach or like that. So this is the first solution, that is using extra space. So for this we have on time and on space. So in this we are given an input array as this 0, 1, 0, 3 and 12. So the output should be 1, 3, 12 and 0 and 0. So we should move the zeros at the end of the array. So this is the pseudocode for the same. So first we need to make an auxiliary array, and then we need to iterate through the original array. We will iterate through the original array, that is 0, 1. Just let me write the elements 0, 1, 0, 3 and 12. So these are the elements. So we need to iterate through them and keep adding the non-zero elements to the auxiliary array. So we have like made a new array here. So we will add the elements that are non-zero in that array. So that would be 1, 3 and 12. And we need simultaneously we need to keep the count of the zero for the counter of the zero elements. So we need to keep the count of zero elements. So as we are moving the elements to the new array, we will also count the number of zeros. After we are done iterating through the array, we will use the counter to store the zero values to the end of the array. So we will iterate the loop like for I is equal to 0 to the counter, that is counter of the 0. So if it is 0, if it is having 2, then we will add 2 zeros at the end of it. So this is a fairly easy solution, but it will take on space complexity. So we can perform better and optimize it more further with using a constant space. So this would be the constant space solution. In this, like we are given an array, so we will maintain two pointers, that is one would be the left and other would be the moving pointer that would iterate to the array, and left pointer will keep the track of where we are adding the elements, the elements in the sorted way that we are trying to move the zeros to the end of the array. So in this we need to initialize two variables. I am taking the name as left and moving. So left will stay at the starting and it will increment only when we have a non-zero value, and moving will iterate through the whole array. So one variable will iterate through the array, that is moving from 0 to n-1, and if the element is non-zero, then we will swap the values of L and R, L and moving, and then increment left pointer. Then only we will increment the left pointer. Moving pointer will keep incrementing as we need to iterate it to the array. So after that run a loop till left is less than length, then we will add the zeros in the array. So we will try run this pseudocode on this example. So in this we have indexes 0 to 4, and these are the elements 0, 1, 0, 3 and 12. So we need to iterate through this array and move all zeros to the end of the array. So this is our left pointer and this is our mid pointer. It will iterate through 0 to n-1, that is 0 to 4. So first of all we will check if value of m is non-zero. It is 0. So we will go to next element and do nothing here. So we will go to next element, that is 1. It is non-zero, so it will check if the value of element is not 0. So we will swap the value of left pointer. We will not swap, we will copy this value to 0. So 0th index. So we will copy this here and it will remain 1, and then we will increment the L as we have copied, because we need not to like keep swap the elements, because we know all elements, all 0 elements should be moved to 0 at the end of the index. So we can overwrite that. So now next moving pointer will move to the next index, that is 0 2 index, and the element is 0, so nothing will happen. We need not to swap this. So moving pointer will move to the next element, that is 3. So 3 is non-zero, so it will check it is non-zero. And now we need to copy 3 to this index, that is left. So we will copy 3 here and increment the left counter, so it will come here. Now moving counter will increment to the next value, that is 12. So it is non-zero, so it will again copy this element or 12 value to the left pointer's index. So it will be copied here. Now left pointer will be incremented. So now we are done with the non-zero elements moved to the front of the array. Now we need to override these elements as 0. We need to move the zeros. So we will run from like L will run from the index which is from like it is at 3 presently. So we will run a loop while L is less than the n, that is n is 5 and L is 3 is less than 5. So now we will see if it is 3. Yes, it is true, that condition is true. So we will override the value, that is L, and the value will be overwritten as 0. So this is what we are trying to do, overwriting the values afterwards, and now it will become 0. And now L will be incremented. After the L is incremented, it will come to this index and it will become 4. And 4 is still less than 5, so we will again overwrite this value as 0, and this will be our final output. And now you can see we have a array in sorted format that we wanted, like 1, 3, 12 and 0 should be at afterwards. So this we maintained the relative order also, so it took only the constant space and on time. We did only one traversal and then adding the 0 elements and overwriting the values. So we will see the solution on the LeetCode platform and submit the code. So I've written the C++ code here. So I will also share the code in the description, Python as well as in C++. So you can copy it from there or either refer it from there if you have any doubts. So this is our function. We are given an vector of numbers. So we need to initialize the first pointer, that is j, or you can write it as left, and then we will move. We will be having the another index, that is the moving index, that is I. So we will iterate the I from 0 to length of the array. So as we move further, if the element is non-zero, then we will copy it to the left pointer. So and we will increment it in the same, it will save one line also. So we increment the pointers L and moving pointer, and then when we have iterated to the array and we have like moved all the non-zero elements to the front of the array, then we will override the values and make the values as 0. So now we will run the code. Just a second. Maybe, yeah, I don't know how I mistyped that. So we have got our first testing is correct. So now we'll submit the solution, and yeah, it got accepted. So it took only just 8 milliseconds, and the memory also, it was faster than 92% of the other solutions. So you can see this was a easy solution, as we just need to keep the track of only the 0 and move the non-zero elements to the front of the array. Thanks guys for watching this video. Do subscribe and like this video and share with your friends. And if you more questions, then you can do comment down below for the questions that you need me to solve. Thank you for watching guys. Do subscribe.